So we're going to look at intervals of increase, decrease, and intervals where our graph is constant. We're also going to look at minimums and maximums. So let's take a look at this graph. An increasing interval will be where the graph is rising from left to right. So let's notice that this graph is rising, and we can assume that's going down forever. At least it's meant to be. So it's rising from all the way here to right here. It's also rising from right here up to here. And it's also rising from here to here. So those are all intervals where it's increasing. Now, if I assume that this is going forever to the left, we'll have this first interval. We always list it by its x values. So really, forever to the left is going to be a negative infinity on the x-axis. And this point right here is actually the point -3, 5. When we list intervals of increase, we list only the x values. So this graph, I'm going to list the increase first, has 3 intervals where it's increasing, where it's rising from left to right. The first interval will be x values of negative infinity out here to this -3. So negative infinity to -3. And we'll just use open intervals when listing increasing intervals. Okay, so let's notice it's also increasing starting from here all the way up to here. So this has an x value of 0. And this point over here, if we think of its x value, it has a value of 3, 1, 2, 3, 4, 5. I think this must have been 6. 1, 2, 3, 4, 5, 6. It was. I just miscounted a while ago. So this actually was a 6 for the y value. And this is 3, 5. All right, so our interval of increase starts at 0 for the x value and goes to 3. Always by x values. You notice that I did not list the y values. All right, now here's another interval where it increases from right here all the way up to right here. And it didn't continue to draw as I went over it. But all right, let's notice that x value is 1, 2, 3, 4, 5, 6. That is supposed to be an open parenthesis. And then this x value over here is 7, 8. And it does end right there. That's a solid dot. So it's not infinity. It's actually ends with 8. So there's my intervals of increase. Now let's do decrease. Now decrease will be where the graph is falling from left to right. And really, if we look at this, there is only one interval where this graph is falling from left to right, and that's from here down to here. All right, so notice that the x value right here starts at -3, and then the x value right here where it stops decreasing is 0. So -3 to 0. Again, we must list this by x values. If we include y values, we will be counted wrong. All right, now, lastly, let's find the intervals where the graph is constant. And when the graph is constant, it is horizontal. So there is a place on here where their graph is horizontal, and that's from here to here. Again, we're going to list that interval by its x values. So certainly it starts right here at the 3, and it goes right here to 1, 2, 3, 4, 5, 6. This point is 6, 5. So from 3 to 6, x values only for intervals where it is constant. Notice that in all of these, increasing, decreasing, and constant, we did not put y values in those parentheses. All right, now, one more, really two more definitions. Maximums and minimums. A maximum is a high point or a mountain on a graph. So let's notice that there's a maximum at negative 3, 5. It's the top of a hill. There's also a minimum right here at 0, 0. It is the bottom of a valley. And we will call these relative maximums and relative minimums because they're high points in comparison to everything that is close to them. And this is a low point in comparison to everything that's close to them. But notice that really this down here, there are points that are lower than 0, 0. So relative maximum, relative minimum. Together, they're referred to as relative extrema. And those of you going on to calculus will see a lot more of relative extrema. So we also have absolute maximum and absolute minimums, or absolute extrema, and that is an M. Just can't draw very well. All right, but this has an absolute maximum will be absolutely the highest point on the graph. Nothing will be higher. So let's notice that this point right here, which is 1, 2, 3, 4, 5, 6, 7, 8, which is at 8, 1, 2, 3, 4, 5, 6, 7, 8, 8. 8, 8 is the absolute maximum on this graph, and it's not letting me put the y value of 8, so it's the 0.88 right there. That's my absolute maximum. It's absolutely the highest point on the entire graph. Now, since this goes forever downward, there is no absolute minimum because we could list a point here, but we could always find something smaller by going further down on that line. So notice there doesn't have to be an absolute maximum and an absolute minimum. And of course, we will have relative extrema if it's going up and down.